So in this example we have biological data which has been predefined. So if we look at the data, we can see that it's recording the length in jaw bones in millimeters of golden jackals from male and female specimens. So the first column lists measurements in millimeters for all the females, and the second column lists measures in millimeters for all the males. And there are 20 subjects in total, 10 females, 10 males. Now this data has been pre-processed by someone, so it's not in the proper data structure for carrying out statistical analysis. What I mean by that is that each column is not a separate variable and each row is not a separate subject. So if we take an example, we can see that this column is jawbone lengths, and this column is also jawbone lengths, and this row does not represent one subject but two subjects. So we need to reorganize the data so that we have two columns, one for jawbone length and one for sex, and that looks as follows. And this is the proper data structure. Here we have the standard data structure for statistical analysis, where each row is a subject and each column is a variable. So you can see that this represents that first male there. The jawbone length is 120 and the sex is male. The second is there and the third is here. And then the first three females, 110, 111 and 107. And then we would have further rows. So in this case there are 20 subjects. That means there are 20 rows in our statistical database. And there are two variables, length of jawbone and sex, so we have two columns. So that data is properly structured for statistical analysis. Here we have another example of a data recording problem. In this example, the data concerns the number of breaks in woolen yarn. So we have two types of yarn, type A and type B yarn. And for each type of yarn, the loom is put at a high, low or medium tension. So there are 54 subjects, 54 pieces of data. So for example, for yarn type A on a high tension loom, there are 36 breaks in this instance. And for yarn type B on a medium tension loom, there's 39 breaks in this example data item. So in fact we actually have 54 subjects, so there should be 54 rows of data, and we have three variables: the yarn type, the level of tension, and the actual breaks. So the proper data structure for that is three columns, one for each variable. So the breaks is a scalar variable. It's ratio data starting at 0 to n. The wool type is a nominal variable, A or B, and the tension on the looms is an ordinal variable, high, low or medium. And that's a proper data recording structure for that data. And this will go down for 54 rows. This is the fourth and final example of data recording, and here we have another set of data from a biological statistical exercise. So here we have three locations. Lower, middle and upper. Lower, middle and upper. And at each location there are two habitats, the closed habitat and the open habitat. And for each location and habitat type there are three species, species A, B or C. And then there's a count of the number of species at each of these intersections. So for instance, at the lower location for the closed habitat, species B, there's a count of 5. At the upper location for an open habitat, species C has a count of 45. So two questions and then a third, and then construct a data file. So the question is, what is n? What are the number of subjects that we're dealing with? That'll tell you how many rows you have to construct. And secondly, what are the variables? That'll tell you the number of columns you need to construct. So I'd like you to do an exercise as assignment 2, and in that work out the number of rows and columns. You don't need to create the full new table. As I did in previous exercises, you just need to create the first few rows. So you've been provided with assignment 2 with an Excel file with this data, and I'd like you to complete that for assignment 2.